All right, so this question has to deal with some carbon atoms in ethylene, and we are told here in question number 3 that the carbon atoms in ethylene are a certain distance apart, 134 picometers. So we want to convert that to meters, basically. So this is going to boil down to a unit conversion. Unit conversions are actually pretty important in this chemistry class. It's not just an issue of unit conversion. It's more of one involving what's called dimensional analysis. And it's kind of oftentimes presents as unit conversions, but it's really the relation of one quantity to another with just different units. So here we're converting between picometers and meters, but this could actually present itself multiple different ways throughout your chemistry classes. All right, but before we start, let's take a look at this very specific problem, okay? So interestingly enough, we're talking about a chemical that's called ethylene, okay? Now, just getting ahead of ourselves a little bit, but when you see this ENE ending in hydrocarbons, basically what that means is that there's a double bond present. It's called an alkene, as it turns out. An ethylene means that there's 2 carbons present. That prefix eth means 2. Meth with the M is 1, and ethylene is 2. So there's 2 carbons in a double bond. So that tells me right away that there's 2 carbons, double bond between them. And then ethylene would have also 2 hydrogens, or 2 hydrogens for each carbon, so 4 total. And it would have the formula C2H4, and that's actually what the formula looks like. So interestingly enough, in this problem, we are told that if I measure the distance between these 2 carbon atoms, between the nuclei of those 2 carbon atoms, that would be 134 picometers. That is the distance between them. Now, as it turns out, that distance is not fixed. All chemical bonds vibrate around an equilibrium bond length or distance, okay? So while we say 134 picometers, that's the average distance. Sometimes it'll be a little shorter, sometimes a little bit longer, as it turns out. But it gives us an idea of what the lengths of chemical bonds are, or the distances between atoms involved in these bonds. In this particular organic molecule, it's a hydrocarbon. But these bond lengths are reasonably similar to other bonds as well, okay? Some bonds will be longer, some bonds will be shorter, depending on what's bonded, and we can get to that later in the semester, okay? But this just gives us kind of an overview or an idea of what a typical bond length in a molecule might be, measured in picometer units here, all right? Now, the question itself wants to deal with dimensional analysis. We want to do a unit conversion. And what I'd like to do to help us do this is work down here at the bottom. And I want to set up for you, oh my goodness, a foolproof way. My pen is giving me trouble. A foolproof way to do these unit conversions, right? A lot of students will struggle with this sometimes, and I don't want that to be the case for you, because it turns out that if you practice this a little bit, you can get this down and nail it every time, all right? And that's what we want to sort of get at. Now, there's a couple things that I think you need to learn to get to that level of proficiency. One thing that you're going to need to learn is more or less this table or chart, which is on page 14 of your textbook, okay? And this particular table more or less gives us some conversion factors, as we're going to call them here in a second. But these are very specific conversion factors. These are decimal prefixes that physical scientists often use with the base so-called SI unit, which stands for System International. That's also outlined there in chapter 1 of your book. You've probably seen this before, okay? But it's sort of this base unit of measures that physical scientists use globally, these SI units. And sometimes, depending on what you're interested in, what your research area is, or what you're working on, some quantities you may need to measure are exceedingly tiny. And then other times, things that you need to measure are humongous. Like, what if you wanted to measure all the water? How many grams of water are in the world's oceans? It's a huge, huge, huge number, right? So because we're faced with making these measurements over, roughly 10 to the 50, say, range, we come up with these metric prefixes that we can use with the base SI units to scale up or scale down. And that's all this table really does for us, okay? So you want to review these. Some we're going to use more commonly than others, but you want to know them for this conversion bit. So we start with tera, giga, mega. These are very big units of measure. And then down at the bottom, we have deci, centi, milli, micro, nano, and pico. These are the really, really small units of measure. The ones up top are very, very big quantities. All right. So in this particular case, we are dealing with 134 picometers. And if we notice where that's at on our table, wow, that's way down here at the small end. 10 to the minus 12th is the meaning of that one. So basically what that means is if we were to measure that bond distance, that bond length in the carbon atom, boy, those carbon atoms are really, really, really close together. Way closer than we could ever see with a typical microscope, okay? They're about 1,000,000 times closer than what we would see with a microscope. No chance if we had an optical microscope to see these. They are that close together. So very, very, very close. But again, our task is to convert picometers to meters. How do we do it? So now that we're introduced to this chart, okay, we know we have to do a unit conversion. Let's talk about the foolproof approach. The first thing I do, and I usually try to do this linearly, one step at a time. I start with the number that I know and that I want to convert away from. Here, that's 134 picometers. I write the number, I write the unit. Because a number by itself, without the unit, it's meaningless. You have to have both components to a measurement, the value and the unit of measure. And then what I do is I'm going to set up a multiplication. I'm going to multiply that value by a number that I call the conversion factor. The conversion factor is always a fraction. So I write a number in parentheses and make it a fraction. That's how I start this problem. I take the number I know and I'm going to multiply it by the conversion factor. Now, the hard part about this is figuring out what the conversion factor is. So far, so good, right? We always start the same way. So what we do next, just to try to figure out what this conversion factor is going to be, is we take the unit of measure that I want to convert away from. We figure out what that is. Now here, that's picometer. And I write that unit of measure, the same one down here on the bottom of my fraction. I call that my undesired unit. The one that goes in the denominator is the undesired unit. It's the one I want to get rid of. So I put it down in the denominator so that when I do my multiplication, it turns out those units are going to cancel out and go away mathematically, okay? So you always put your undesirable unit in the bottom first. Then up top, what you do is you write in your desired unit. Now in this problem, I want to convert to meters. So meters is my desired unit. So I'm going to put that up top, M. Now the only thing that's left to do for me is to figure out what numbers to put into this conversion factor. That's all that's left. I've got to put some numbers in, then I can do the math and get at my answer. This is my last step. So what do I do for that? Well, what I do is I essentially use this chart with the appropriate entry. Now I want pico, and pico is the one that's down here. Okay. And what does this chart tell me? It tells me that 1 picometer, 1 PM, is equal to 1 times 10 to the minus 12th meters. And I'm going to use this to my advantage. I'm going to say 1 picometer is equal to 1 times 10 to the minus 12 meters. So then what does this conversion factor become? Well, the conversion factor, this fraction, I like to say, are two quantities which are physically equivalent, but just have different units. These two numbers are physically equivalent. They're the same distance. 1 picometer is equal to 1 times 10 to the minus 12 meters. If I was to measure both of those, I'd get exactly the same length, like exactly the same distance, no difference. They just have different units of measure, don't they? And that's all we're doing here. That's all we're doing here. So by carefully crafting our conversion factor, I can cancel out my undesired units of picometers. Oops, I didn't want to do that. I can cancel out my undesired unit of picometers and be left with meters after I do my math. And that's what I'm going to do. So if I multiply those numbers, I'll end up getting 1.34 times 10 to the minus 10th in meters. And that'll end up being my answer, okay? Now, here's the thing. I went through this and kind of showed you how to do it, but let's think about what you as a student would need to know if you're going to do this on your own, on a homework assignment or on the exam, right? Because this type of thing, it could very well be on the first exam. Let's talk about that. The first thing that I think you need to know to help you figure out how to do this is this general approach down at the bottom of the slide that I told you about. Think about what I did again. I started with a number that I knew that I wanted to convert away from, that's typically given in the problem. Here that was this 134 picometers. I started with that and the unit of measure, because remember, anything we measure, it has a value and a unit. You have to report both, very important. And then I took that number and I simply multiplied it by my conversion factor. Remember how I set that up? Very specifically. I put a number in parentheses that was a fraction, my undesired unit in the bottom of the fraction. I did that first intentionally. Undesired unit in the bottom, desired unit in the top. The unit I want to convert to goes up top here. That was meters. That was my desired unit. I always do that first. And the reason why is so I don't confuse myself which number goes where. If students tend to make mistakes with this, they forget, oh, do I have to multiply by this number? Do I divide? What number goes where? Work the units first, and that tells you what to do, basically. Always put your undesirable down here so that it cancels out. And if you remember that, you can succeed even if you're not sure what number goes where, okay? It's just you follow this protocol, and it just works because it's the correct way to do it. Desired unit up top, undesired unit in the bottom. Now, the next thing that you need to remember is the value for the conversion factor itself. Now here, I'll give you this table. Now this is on page 14 of your book. I don't know, sometimes people make note cards or something like that to try to remember these values, okay? But the thing is that these values in this table will not be given on the exam, so you're gonna have to remember what they are, okay? You're gonna have to remember what these values are, familiarize yourself with them. You're going to see these in all your physical science classes because they're common decimal prefixes that we're always using in the metric system. I know that you've probably seen many of these before, but you want to brush up your knowledge of that, okay? You'll see this more in this homework. You're going to see it on the exam. I'm very certain of that, okay? So you'll want to commit these to memory. And the key reason why is because you need to know the numbers to write in your conversion factor, which are physically equivalent. Remember it. These numbers in the numerator and the denominator are physically equivalent. They're the same distance. They just have different units of measure. So once we realize that, we plug in the appropriate place and we solve the math problem. And it's as easy as that. You can always get these ones right, okay? So I want you to do that. So keep in mind what we talked about here. I know I've been a little bit long-winded going through this problem, but if you struggle with this, some people do, some people don't. Either way is okay, right? But if you struggle with this, spend a little time on looking at this really systematic approach to doing unit conversions, because you can indeed get these right each and every time, all right? That's that.